Now, again back with the headphone and continuously playing with that. I know I'm going to get a huge scolding today, like you sometimes get. But right now, what if I now, instead of leaving it like that, lost? Okay, let's try it again, because this will be one more demo. In fact, I am just going to straighten it and I am going to use it with a more straight device. Now, what is the usefulness of using this one? This one is already having a rigid structure. Please don't try with this at home, but because what I am going to do right now is, so every time when I am throwing a device, that means after creating a uniform circular path or motion continuously, when I am just leaving it, it's not coming back to the center. What is the difference right now? The difference is, over there I was slowing down the force and then stopping it. That means the external force amount was changing. Over here I am coming to a sudden stop, and that's why the thing is already in the inertia of, correct, inertia of motion. Now what is happening? Let's see with one more ultimate demo, that is with this one. Now I hope most of you right now can easily or clearly see this. The whole tub is now visible at this point. So if I suppose you noticed what happened, that is, the ball simply flew out of the bucket and went away somewhere else. I had to again pick that up and bring it. Now, for the demo, what is happening? When I am forcing or giving the force to the bucket, the body continuously moves and maintains a uniform speed. But when I suddenly leave that, the body does not get a chance to come to stop or slow down or retard and then stop. Result, in its inertia of motion, it continues to follow the same path. So over here, as much if I am leaving it from this position and the bucket is not enclosing it, so from this position after leaving, it goes out. Again, from this position, if it is not enclosed by this side of the track, it just goes out. Now, this type of force which is generated due to this track effect, I will call it a track effect always, because the body in this case has no function of its own. The body is not providing any other separate type of force. It is just doing its own work continuously. That is, while you sit in the exam and you continuously write, it's a long paper and you are very stuck at the mind, what is it going and what will it be, and suddenly the bell rings. You don't care of the time. So similarly, this is the same thing, that the body which is continuously in its motion and staying in its uniform speed does not know that the track is going to get moved. So it continues to be in its path of motion. Now the force generated in this way, as you saw, is quite a strong one, and the body even has the risk to fly at a longer distance. This is termed as the centrifugal force. That means away from the center or away from the track. The difference between the centripetal and centrifugal forces are many. We don't go into deep detailing of 10-12 pages like that, but a short one for your standard right now. That is, for centripetal, it will come slowly at rest. For centrifugal, it is the effect of the track. It is not the effect of from the body. So, there is one word written, a force assumed by an observer. Kindly remember this. I am observing it. If I would be inside, that more examples I am giving. In this case, this force is not the generation of the body itself. The body is just continuing to be in motion. But this force generated is the centrifugal. The force assumed to be acting on the body in a direction away from the center of circular path. Now, there is one important term given, and this is the question, might be of reasoning, might be just only to know, that is, centrifugal force is not a real force. It is written in italics on the same page in which we were, that is page number 16. Underline it, and it is a good question. Every now and then it can be asked, why? Why centrifugal force is not a real force? It is a fictitious force assumed by an observer moving in a circular path. Now, coming to the observer part. As previously I asked, and there were some queries, that many of you do ride a bicycle. Now, there is a nature of us that when we ride on a straight path, we can ride at a good speed of us. But when we do turn, or while turning like this, we have a tendency to slow down. What will happen if I don't slow down and another vehicle comes? In that case, I am supposed to be just thrown away and can cause real harm to myself, or you can cause a real harm to yourself. Now, the cycle or the car, when it is moving in a round path, the body being in an inertia, tendency to be in motion, already is gaining a certain amount of force, and hit by another body, or if not controlled properly, then why instead of going in this particular way, it can go in this and crash. So, this is the reason why we slow down. Action of centrifugal force, which is not a true force at all. A good example I would like all of you to see, that is, when do you have any idea of car racing? Nowadays PUBG is very popular, but when we were young, car racing games were very popular. I don't know whether you have it till date or not. Asphalt, Road Rash, or something like that, car, NFS. In that case, you might be noticed that when the car is running at a very high speed, the tracks over here away from the cart track are slightly risen or at an inclination. Here is the track and here is the car at here is the car and here is the track at slight an angle. It is not exactly at the same level of the road. Why? When the car is racing, it is not running as it runs on our busy roads, 20 kilometer, 30 kilometer. It can be at 120 or 130 kilometer per hour also. So, what happens if there is any problem in the car? Many a times we can see that suddenly due to a car accident, there are many movies also, there are many news headlines also, that the car is just being upside down, the driver is facing injuries, the people are coming and saving them. But why this is done? This rising up or the inclination of the land is known as banking. It has no need to deal with our normal banks and customer care and money. It is just the river banks you must have heard on, which is at a slightly higher distances and or at a higher height, at a good height sometimes. Similarly, this is also done and the audience sits somewhere at a good height from here. So that if the car is out of its track or not controlled sometimes, if there is a tendency to move out of the track, the car will stop here only, might be after this upside down. It will not just go and directly crash some audience over there, because if a car hits someone amongst the audience, it will actually not hit someone amongst the audience, it can hit a bunch of audience, leaving them bye-bye from the world. So, this banking is done so the car can be saved. Not only that, the audience can be saved. So, this centrifugal force is really, though being a pseudo force, gives so much impact that these type of constructions also need to be done. There are good examples in your book, that is breaking of a string or that of the merry-go-round. In this case, that is, they are talking about, you must have heard about the merry-go-rounds. I don't have any certain example related to that. For the time being, I can show that this can be the center point and the merry-go-round just go on like this. Many a times people are very scared from merry-go-round or they just keep on shouting. What happens if any of the seat is torn? Huge accident. The seat will just go and land the person somewhere else, we don't know, and it will be immense danger or maybe the end of the person's life. So, this type of effect can be caused. So, it is not that the centrifugal force is only dangerous. It can be useful. There is a separate machine which is used in biolabs or biochemical labs for testing, which is centrifuge, and it is used to separate out the heavier blood materials from the lighter chemical blood materials, and when it just rotates, what happens? It just straightens out. There are test tube fixed at the ends, and when it rotates just like this, it goes on separating out the materials and the test tubes at the end, which keeps hanging from the first. When the force rotation is started, the test tubes become horizontal like this, and after that the things are separated. So, the centrifugal force do finds its applications also, but even after these huge effects, the centrifugal force is not a real force. It is a basic inertia of the body, the inertia of motion in which the body continues to stay. So, this portion, there is a last conclusion which I am reading out. Kindly underline, the centrifugal force is not a real force, it is a fictitious force Previously also it was written that it is not a real force. A force which really does not exist but is considered to describe a certain motion is the fictitious force or virtual force. So, any of these terms can be used to question why is centrifugal force a virtual force, why is centrifugal force is not a real force, why is centrifugal force is a fictitious force. Answer in every case will always be the same. So, this was the end for the explanation of the chapter. We will be coming up soon with the next important portions, might be the question answers also. Please go through the book by the time and read it carefully. It's a request because book is the ultimate solution rather than your ready-made question answer, textbooks, last year's question and everything. Concise book is clearly written according to the ICSE syllabus. So, please go through it at least once line by line before switching off or jumping off into the question answers from the first time itself. Once you read the book, you understand, your concept is clear, you can definitely give the question answers a turn, or you can use your concept to answer any type of questions. Thank you.